Before I get into making more parts for the brakes, I'll cover off a couple of catch-up jobs. Firstly, I need to attach the eccentric for the boiler feed pump to the leading axle. As I decided not to make it a split eccentric, I needed to drop one of the wheels off the axle, which coincided nicely with me wanting to use a finish wheel as a guide for the taper on the brake shoes. So I went ahead, stripped the valve gear off the loco chassis, removed the leading axle, and using some heat dropped off both the wheels. Before fully reassembling the wheel set, I used a slot drill to put a flat across the centre of the axle and drill a small indent for the grub screw in the eccentric to locate into. Another job that I've been putting off for far too long is the soldering of the motion brackets. As I called out in an earlier video, making these has been a challenge with multiple attempts before eventually getting them right, and even then I had to use some shim stock when assembling them to the frames. Soldering these should be a simple job, bearing in mind that there is a large surface area, so bringing the parts up to soldering temperature will require some shielding. After leaving each set of parts to soak overnight in some citric acid pickle, I clean up the jointing faces with some emery and then reassemble using flux on the joint faces and on the sacrificial screws. Using some offcuts of vermiculite and some ceramic wool, I cover up as much of the surface area as possible, and as I normally do, I place some small pieces of solder against the joints and then apply the heat. After another overnight soak in the pickle bath, we can see that the capillary action has worked well and that the solder has flowed nicely into the joints and around the various sacrificial screws. This means that I can now remove the screws with a bit of filing and clean up with some emery. With those jobs out of the way, I can get back to the outstanding parts of the brake gear. First, I'll tackle the handle and the associated column. The handle is simple, comprising of a long 4mm diameter shaft threaded at one end and with a bush and a cranked handle at the other. The column is also quite simple, with a recess at the top for the bush on the handle's shaft and a threaded shoulder at the bottom to secure it in place. The bulk of the body is tapered. For the handle, I cut a length of 4mm bar and face off both ends, bringing it to length. I then cut the 532 by 32 TPI thread. Next, I mark the bottom position of the collar with a sharp pointed tool. We'll come back to this later. It's then onto the milling machine to drill through for the cranked handle. For the collar, I turn down some 7mm bar to 6.4mm, drill through at 4mm, part off and then face to length. To solder the collar in place, I have centre popped the shaft to make the collar a tightish fit, and I position it by eye to the line I marked earlier whilst in the lathe. I apply some flux and solder into place. The bush is blackened because this is my second attempt. I dropped the solder the first time. However, both the bore and the ends of the bush have been thoroughly cleaned. As I don't have a suitably sized bender, I use a bit of bar as a former and some heat to bend the handle to shape. The result is as expected for such a crude approach. Ideally I would solder this in position, but given its poor shape and that I'm certain it will get bent out of shape in the near future, I'd Loctite it instead. This will make it a lot easier to swap later. I use a piece of 1/2 inch bar for the column, facing off the ends to bring it to length. It needs to be drilled all the way through at 4mm, but at 96mm long I'm not going to manage that with my usual drills. I start with a stub drill, then move on to a normal twist drill, taking this in as far as possible. I did buy a set of cheap long drills from eBay, but not surprisingly given the cost they are pretty useless. So I swap the workpiece around and drill in as far as possible from the other end. The drill bit is just long enough to break through. I do then run all the way through with the long drill bit. A quick test with the handle and it would appear that I'm good to go. One end needs to be counterbored at 6.4mm diameter to a depth of 9.5mm. First I use a parallel to establish a reference and then rough out the bore with a 6mm drill to a depth of around 9mm. To complete the counter bore I swap out the drill for an old 1/4 inch drill on which I've ground the tip flat. I've taken this approach previously with mixed results, but a bit more focus this time on using a diamond file to give some rake on the back of the cutting faces produces a decent result. However, when I do a trial fit, the bush on the brake handle does not fit in the full depth of the bore. It takes me a while, but I eventually track it down to the drill bit being worn at the tip. I can only assume I'd given it some serious abuse at some time in the past. To resolve the issue, I regrind the flat end of the drill past the wear on the diameter and then clean up the bottom of the counter bore. At the other end I turn down a shoulder and cut the 532 by 32 TPI thread. Before I swap out the chuck, I use a sharp tool to mark out the top of the tapered section. To turn the taper I'm going to offset the tailstock. I did think about using the compound slide, but at 80mm in length I think the tapered section is too long and getting a good finish without a power feed will be difficult. I'll come back to finish later. Offsetting the tailstock will not be difficult, not least as I'm not looking for high precision. The taper is cosmetic, so it just needs to look good. Setting the tailstock back, however, will be a challenge. It took me hours to get it right when I last did it, but that's for the future. As you can see here, to offset it I use a dial gauge and move the tailstock by half the difference in the diameter at the top and the bottom of the taper, 1.6mm. In terms of setup, I've got a centre located in the lathe spindle with the faceplate fitted. Using one of my recently drilled holes, I've fitted a length of threaded bar which will drive the dog, and I've also got the live centre in the tailstock. Because most of the column is tapered, I only have a narrow section to fix the dog to, so I make one from some 8mm flat bar. I do fit a small piece of brass so that the lock screw does not damage the surface finish. It's not at all evident in the video, but I have actually spent quite a bit of time getting everything positioned before I fit the column between the centres. And even so, I do a few more checks before applying power. I have commented previously about my inability to get a decent finish on this lathe with my old steel, particularly when using HSS tooling. As a result, I did have a comment from WizRom against part 53, where he noted that the poor finish was likely down to the tool geometry rather than the machine. As a result, I have been working on my grinding, and although I wouldn't call this a spectacular finish, it is a significant improvement on what I used to get, so good advice from WizRom. Thank you. I still give it a polish with some fine emery and a Scotch-Brite pad, and with the latter I am being very careful on where my fingers are. With the column and handle completed, I am making good progress with the brakes, but there are still a few more parts to be made, and I'll continue with those into the next video. Thanks for watching.